Okay, let's get started.
Oh,
Yeah. So we are going to start with the module 1, which is the dynamics.
okay.
Yeah, and on dynamics, we have got these objectives to look at, scalar and vector.
Okay.
Yeah, we need to be able to differentiate what is scalar, what is vector. Then we come to distance and displacement. Then speed and velocity. Then acceleration, retardation. Then we come to graphs.
Okay.
Yeah, some of the other stuff we'll fuse in as we discuss.
Okay.
Yes. So now let's look at the scalar. What do we say scalar is? So scalar is any quantity that has got magnitude but does not have direction.
Okay.
So any quantity, so this is any quantity that has magnitude but has no direction. Example, we have so many quantities that you find that there is magnitude, but you can't specify direction, such as time. Time does not have direction.
No, just in circles.
You see? Yeah. So we have got time. Besides time, we have got temperature. These are scalar quantities. Even distance itself, when we are measuring to say what is the length of something, you can't say specify direction, you just say what's the length.
Yes.
Yes. So distance, mass, all these I'll say ETC, end of my thinking capacity. So
Okay.
time, temperature, distance, mass, all these are considered as scalar quantities. Why? Because they have the magnitude, which is the size, but you cannot specify what direction they have.
Yes.
Okay. So that is what is the scalar itself.
Scalar now.
Yeah. Then we have got the vector quantities. Vector. So vector is direct opposite of scalar. So this is any quantity or matter that has got magnitude and it has direction. So this is any quantity that has magnitude and direction. E.g., example, we have got the like displacement. Displacement you state to say 10 kilometers northeast.
No. Yes.
So displacement has got a specific direction. So we have got the displacement, we have velocity. In fact, here we can even add speed.
Okay. Oh.
Yeah. So here we have velocity, we have acceleration, we have got the force, and so on. So these are quantities with that in themselves they have got magnitude and direction. These are the quantities with magnitude and direction. That is why we call them vector quantities.
Vector quantities.
Yes. So in terms of just to analyze them further, when we are comparing these vector quantities, you find that if it is scalar, we'll just say 10 meters. But if this is scalar. But if it is this vector, we'll say 10 meters east. So this one is 10 meters. It doesn't specify direction. This one is 10 meters east. It has got direction.
Yes.
Okay, just a minute. Okay, so we have already started. What I was explaining is the scalar and vector. So in the definition, we say scalar, this is any quantity that has magnitude, but it does not have direction. So to be specific, the examples is time, temperature, distance, mass, speed. All these, they have got quantities. So like speed, you can say 10 kilometers per hour. Like the readings in the car, on the car speedometer, just say 10 kilometers per hour. But which direction, it doesn't state. So that one is just a quantity. It does not have direction. But if we say 10 kilometers per hour, northeast, it is no longer a scalar. Because it has got quantity and direction. Then it will fall under what? Vector. Because vector, this is any quantity that has magnitude and direction, e.g. displacement, velocity, acceleration, force, power, and so on. All these, they have got the magnitude and the direction. And here there is a scalar quantity, just say 10 meters or 25 degrees Celsius. If it is a vector, we have 10 meters east. So these are examples you can get. Is there any question?
Not from my side.
Okay?
None.
Okay, thank you. Now, let us elaborate more on these two by using distance and the displacement. So we have distance. What is distance? We say distance is a scalar quantity. How would you define distance?
Good question.
How would you define distance?
Something that's
How to describe displacement over time?
So distance is it?
Distance is displacement over time.
Not really. And our colleague, you wanted to say, Mr. Rhino?
No, it's something what not where I am.
Okay. So distance, this is the magnitude of a moving object measured in meters or kilometers, and it does not have any specific direction of its movement. So this is the quantity of a moving the measured quantity in meters or kilometers without any direction specified. So this is the measured quantity in meters or kilometers without. Why I say with? Without any direction specified. That is distance. So it means that displacement is opposite. Before I come to displacement, anyway, we'll draw a diagram to redefine the two. So this is the shortest Okay, so displacement, this is the shortest distance covered by an object in a specified direction, e.g. 10 kilometers northeast, 10 kilometers northeast. Is there any question?
No, makes sense.
Okay, now just to expand these two more.